All right, so let's take a look at this example. We are determining if this is showing direct variation. Now, all the things that we have talked about up to and to this point applies here. So in order for this to be direct variation, it needs to be a straight line, it needs to go through the origin, and it needs to be proportional. So the proportional piece would be that finding that k value. Straight line, you can kind of think of it if you were to draw it, or you can actually draw it out and figure out if it's a straight line. And then does it go through the origin? Sometimes it's a lot more clear to figure that out. Now, if we circle yes here, then we're going to fill out our k values and our equation afterwards. So we have a table here. So the first thing that I'm going to do is what we practiced before, and we're going to put our y value over our x value. So for the first part, we have 1 over -1. Which is going to give us -1. And the next one we have 0 over 0. Now when I look at that and I say, oh, I'm going to get 0 there if I simplify that. Remember, that's okay because direct variation is supposed to go through 0, 0. So you will actually get that for one of your, that 1 point, your origin point, but we'll keep going. The next one is 1 over 1. Okay, here, my first one, I got -1, right, when I simplified, and this one gives me +1, so I can go ahead and stop here because I know this is not direct variation because I got something different. Now, I could keep going, 2 over 2, that's still going to give me 1, but I have this -1 over here, so that first point makes this a no, okay? And what you could say is it is not proportional. Okay. Now, it says if you circled yes, we didn't circle yes, so we're not going to do the next part. All right, let's take a look at this one. So we're doing the same thing. They've given us points here. The first thing I'm going to do is determine if this is proportional by finding our k value. So I'm going to put my y over my x, so I get -1 over -1, which is going to give us 1. 0 over 0, that's my origin, so I'm good there. 1 over 1, that also gives me +1, and 2 over 2 also gives me +1. So we're looking good so far. Now, since we got a k value of 1 here, because each time it was -1 over -1 is 1, 1 over 1 is 1, and 2 over 2 is 1. We know it's proportional, so that goes ahead and tells us it's proportional. So I'm going to add that to my reasoning here. Now, does it go through the origin? Absolutely it does. So it goes through origin. And the last thing, is it a straight line? Now, if you were to plot this on a graph, it is a straight line. So yes, this is a straight line. So that would also be reasoning. I'm not going to show that here because we don't have time, but that would definitely graph straight. Now, so this is a yes, direct variation, it's proportional, it goes through the origin, and it's a straight line. Now, if we circled yes to above, we have to determine what our k value is. Now, I just kind of talked about that here. Our k value is 1, okay? And then they want us to write an equation for this. Now, remember, the equation, when we talked about equations on the previous slide, it's going to be y equals kx. Well, we determined that our k, our constant, or our unit rate is 1 here. So our equation is going to be y equals 1x, or that could be written as y equals x, because you don't have to technically write that 1 there. So that would be the equation for this example. All right, so we're going to do the same thing here. We've got some points. We're going to go ahead and try to find our k to see if it's proportional. So we are going to put our y value 2 over -4. Okay, so we know that's going to simplify to -2. I can write that here. Now, I'm looking here and I notice, based on both of these points, that this graph is not going to go through the origin because we don't have a 0, 0 here. So that's already a red flag, right? If I look at my very last point and I do my y over my x, I do 4 over 2, that's also going to give me a +2 here. So it's not proportional. It doesn't go through the origin. So those are two things right there that already tells us this is going to be a no. Not proportional. Not through origin. So we're not going to fill out these last two questions because it is not a yes above. All right, now let's look at this. Now we're looking at an equation, so a little bit different than what we just talked about. So if I look at this equation, I need to determine if this is direct variation. Well, this is set up perfectly like the first slide, or the slide that we showed you with equations, right? We have, remember, it was y equals kx, and we can see very clearly our k here is 4. So the k is being multiplied by the x. We have y alone. So this absolutely, yes, is direct variation. We know that it's proportional because we have that constant 4. So I'm going to add that. Proportional. Okay. Now, how can we prove the other things? How can we prove this is a straight line? How can we prove that this goes through the origin? Well, besides the fact that this is set up perfectly like what we would expect for a direct variation, we can actually prove it by plugging in values for x. Okay, so our equation is y equals 4x, right? So we want this to go through the origin, correct? So why don't we plug in a value for our x here and see if we get 0 for our y. So if I were to say y equals 4, let's plug in a 0 because it's 0, 0 is what we want, right? 0, 0. If I plug in a 0 for x, I end up getting y equals 0. So when my x is 0, my y is also 0. So this will go through the origin. And this will also graph in a straight line. So you could start plugging in different values for x to figure out what your y is, and you could plot those points, and it will be a straight line. Okay, and it's also because it's proportional, it's going to be a straight line. So since we circled yes above, we need to determine what our k value is. Well, that was pretty simple, right? It's going to be 4. And actually our equation, and they're not even asking for it because they gave it to us in the beginning. Now let's take a look at this one. This is a little bit different. We've got an equation here, and we talked about this before. If we have a plus or a minus, we already know that the answer is going to be no here. But let's talk about it for a second, okay? One of the reasons that this is a no is because if I were to try to see if it goes through the origin, so if I do the same thing and I plug in a 0 for my x here to figure out what my y is, let's do it. So y equals, we're going to do 3 times 0 plus 6. Okay, so order of operations tells us we're going to do 3 times 0 first, which is 0 plus 6. And what happens is we get y equals 6. So when our x is 0 here, our y is 6, which means this does not go through the origin, okay? That, it has to go through the origin for it to be direct variation. Now, it is going to be a straight line, and it is going to be proportional. But since it doesn't go through the origin, this is not direct variation. So we're not going to answer our k there because, like I said, we are not seeing direct variation. All right, and here's our very last one. So for this one, we have an equation here, and it is not set equal to y. This is the first one that we've seen in our examples that isn't set equal to y. So that's the first thing that we need to do is we need to solve this for y to then see if it's direct variation. So right now, our y is being multiplied by 2/5. So we're going to divide both sides by 2/5. Okay, so that we can get our y alone. So when we do that, we do get y on our right-hand side, and then we've got x divided by 2/5. So let's kind of do it like we did before, x over 1 divided by 2/5. Okay, keep, change, flip, so we're going to do x over 1 times 5 over 2, which will give us 5x over 2, which we can write as 5 halves x, or 5 over 2x. That's the same thing. So if I have 5 over 2x, is this direct variation? Well, yes, it is, right? We just flipped it backwards. If I were to flip my equation and do y equals 5 over 2x, you can see very clearly that we've got our x being multiplied by our k, which is 5 over 2, and it's set equal to y. So this is actually going to be a yes for is it direct variation. And then our reasoning here would be that it's going to form a straight line, it's going to go through the origin, and it is proportional. Now on your slide, it should be asking what your k value is here. I don't see it on mine, but the k value here is going to be our 5 halves, or 5 over 2 equals our k value, or our unit rate, or our constant of proportionality. Okay, so try the next few slides. Good luck.